Okay, let's give you guys some more practice. So given this distance time graph, work out the distance traveled between t equals 3 and t equals 13. So work out the distance traveled between these two times here. Okay, so first thing you should do is zoom into here and zoom into here. So identify which graphs we're talking about. Remember, you've got your acceleration time graph. Um, uh, yeah, whenever you get given these questions, try and identify which of the three graphs we're talking about. Here we are talking about this graph here. So if we're talking about this, you know that the gradient of this represents the speed, the gradient of the speed time graph represents the acceleration, and so on. So try and visualize which inside your mind which graphs, which of the three graphs we're talking about. Well, anyway, so given this graph here, work out the distance traveled between time equals 3 and time equals 13. Work out the distance traveled. So press pause and have a go. Now, well, I hope you press pause and have a go already. So here, we are talking about the third graph down. So here it would be the speed time here, and then you've got your distance time graph. Now we are talking about this graph here, and the you see normally the gradient of this graph represents the speed. But here here I'm not asking for the speed. I'm just asking for the actual distance traveled between t equals 3 and t equals 13. Now because we are at the distance time graph, and I want to know the distance traveled, it's just a basic straight reading in this case here. So here, what I mean by basic straight reading is basically we are not working out the area of anything. We are just looking at this number and time equals 3. So we are looking at this number. So the distance traveled is 7 meters. Okay, so what that means is, suppose you and your dad are sitting in the car here. At time equals 0, the car is here. At time equals 3, at time equals 3, the car is 2 meters away from the start. So the car is here at the moment. Okay, and then at 13 seconds, something happens in between, but at 13 seconds, the car is 9 meters away. So the car is 9 meters away. Well, something happens in between, like, well, you start here, and then 3 seconds later, you're here, and then you're stationary for 2 seconds. So it's 1, 2, and then you would move 1 meter after 1 second, and then you're stationary for 1, 2, 3, 4. So 1, 2. Sorry, I'm talking rubbish. You're stationary for 4 seconds. So it's 1, 2, 3, 4. You're stationary. Remember, you're not moving. You're still at 3 meters here. Okay, and then at this point here, you would travel really fast. So here, after 3 seconds, you would have made it to the 9 here, the distance of 9. Well, basically, because I'm asking you what is the distance traveled between time equals 3. Well, at 3 seconds you're at 2 meters. So time equals 3, you're at 2 meters. Okay, it's confusing when, well, it is confusing, but well, time equals 2, you are here. So time equals 13, you are here. So the distance traveled is actually 7 meters. Okay, 7 meters. Sorry, like this. Okay, so hang on. Next question is what is the acceleration at time equals 2? Okay, right at this point here. What is the acceleration when time equals 2? Press pause and have a go. Remember, try to visualize the three graphs. So you are here, and now I'm asking for the acceleration. So it's going to be here, okay, and then here. Well, I am asking about the acceleration here, but you are here at the moment. Well, anyway, do whatever you have to do. So what is the acceleration at time equals 2? So press pause and have a go. Okay, so to answer this question, you should visualize your three graphs. So you've got your acceleration time graph, your speed time graph, and then your last one is distance time graph. Now, you see at this point here, let's just talk about this line here only. The distance time graph is a straight line like this. Okay, so time equals 3 is here. See, time equals 3 is up here. Well, let's just talk about a straight line at the moment like this. Okay, the gradient of this line here represents the speed. So here the gradient of this line here is 1, 2 over 3. Okay, so the gradient here is 2 over 3. So what that means is that the speed is 2 over 3. Okay, so it's a straight line like this. Now, well, when you're given a speed time graph, the gradient of the speed time graph represents the acceleration. So the acceleration of, well, the gradient of this line here is actually 0. So your acceleration time graph will just be a straight line like this, 0. Okay, so when you have a straight line, when you start at a distance time graph and it's a straight line, the gradient of this represents the speed. The speed would be a horizontal line like this. Now, because it's a horizontal line, the gradient of this, or the acceleration, is 0. So you see, the acceleration at that point is actually 0, because look at this. The acceleration at this point here, well, here you've got the distance time graph that looks like this. So the speed time graph will look like this. So, well, here the gradient here is 0. So the acceleration at this point will be 0. Okay, it's only, you only have an acceleration when you have a distance time graph looking like this. Hang on. Looking like a curve like this. You see, well, when it's something like y equals something x squared. When it's an x squared, so when it's a quadratic, hang on, when it's a quadratic, I can't draw properly. So when it's a curve, basically, hang on. So the distance time graph. The only time you have an acceleration is when you well, not the only time, but an example of a time is when here you've got your, because this is a quadratic here, the speed will be like this, will be a straight line. You see, in our case here, the distance time graph is a straight line, so the speed time graph will be constant. Over on this side here, the acceleration here will be constant, whereas the acceleration over here, it would be 0. So when you start at distance time graph, if it's a straight line, the acceleration would be 0. But whereas if you drop a cannonball of a building, it will follow this quadratic curve. Remember, h equals gt squared over 2. You see, this is to the power of 2 here. That's why we get this curve. Now, when we get a curve like this, your speed will be like this, because you're under constant acceleration, the speed will increase all the time. So here you've got a gradient here, so that's why you've got an acceleration. Whereas if you have a straight line here, the speed time graph will be horizontal, meaning the gradient here will be 0. Well, anyway, the acceleration at time equals 2 is 0, and the acceleration when it's here is 0. The acceleration here is 0. The acceleration here is 0. Okay?